Can you hear me?
Yeah, can you hear me okay?
I don't know. I can't hear you for some reason.
Okay.
Well, maybe it's because I'm putting you on the big screen.
Okay.
It's not the best quality, but you're up there.
Okay, is the audio working?
Your audio. Can you test the sound?
No. Yeah. Can you hear what I'm
Cool.
saying?
Can people in the back hear that?
Can you
Yeah.
guys all hear what I'm saying?
Cool.
Okay. So we'll get started at 8:30. We still have a few minutes.
You want me to face the camera towards the audience?
Sure, that'd be great.
Is that good? Hey,
How's it going?
I think it's going good.
Cool.
Kind of strange, but it works. Can you hear the like students when they talk, or I'll just relay, I guess?
I can kind of hear them, but today it'll mostly be me talking. So
Cool. Yeah, there's this crazy microphone.
For the USB.
Yeah.
Great. Oh, you.
So I want to see if I can make a quick announcement about an internship opportunity before the class started. Would that be okay with you guys? I just want to make a quick announcement about internship opportunity for you guys there.
no, we're not doing any announcements because I'm remote, and so it would take too
Sorry,
much
Adina,
organization. So we're
hold
not
on.
doing any announcements this
We
semester.
cannot hear you.
Oh,
Why is it coming out there? Can you try talking again?
yeah. Can you hear me now?
Sorry, not today.
Okay, no worries. If it makes it easier, I can skip to the end of my presentation. It'll only take me like 5 seconds to present my announcement before you guys get started.
I don't think so today.
No
Sorry.
worries. Could I just pass a clipboard around, no announcement, just pass it around to every student, like leave it like that, no announcement?
Yeah, we have to do this. Sorry.
Okay, thank you guys.
Let's see, it says HTML.
Whoop. You guys are a little bit frozen on your end. There we go. You're unfrozen now.
Let's try. Can you try tagging again?
Yeah. Can you hear what I'm saying?
Oh, goodness. Okay. Is this like sound nice to you?
Yeah, I can hear you just fine.
Okay. Can you hear me when I am over here?
Yep, I can hear you.
Oh, yeah, so that microphone's a little bit better. Cool. I think that's everything. Awesome. Thank you so much. It's a huge help.
All right, so it's just about 8:30, so let's get started. So lovely to see you all. I hope you guys had a great winter break. As I outlined in my email, our plan for today, we're going to talk a little bit about the course and the mechanics. We'll go over some Moodle stuff and homework stuff, and then we will start 1.1, which is our review section called What is a Function? So we're going to start, I'm going to tell you a little bit about myself, about the course and all that as we go. And then at the end, if there's questions, I'm happy to answer those. So as you probably know from your registration and from the email I sent you, unless you just joined the class today, my name is Adina. I am totally fine with you calling me Adina. So when you write an email to me or whatever, you can totally use my first name. That's totally fine. I teach obviously in the math department. This is my 16th year teaching, so I've been doing this for a long time. And I mostly teach this class. This is my favorite class to teach. I love working, you know, with underclassmen, and I really love calculus. So a couple other things about me. I did my undergraduate at UMass. So much like you, I sat in a lot of the same courses and even may have had some of the same instructors because no one ever retires from UMass. And I lived on Orchard Hill, and I was a math major. And so now I teach here, obviously. I have 3 kids at home. I have a 14-year-old, I have a 10-year-old, and I have a 6-year-old. And if you're wondering what's going on behind me, that is my 6-year-old's drawings. She has some sort of master plan as she refers to it. So that may evolve as the semester goes on. So in addition to me as your instructor, we have an incredible support team for this course. And so I'm going to ask if the teaching assistants for this section are there, if you guys could stand up and introduce yourself by name, major, and year to the rest of the class so they know who you are, that would be great.
So hi, I'm Xander. I'm a junior. I'm a biochemistry. I'm not making question. This is my first time actually going to math.
Are we good?
Yeah.
Okay. So to give you guys a sense of how the TAs will help us, so you can certainly ask them questions before or after class about the math, but one of their primary responsibilities is they help staff a drop-in help center. So the math department is running all of their help centers remotely again this semester, so these will be on Zoom, but there will be drop-in help most days of the week, and the drop-in help will start tomorrow. We have an organizational meeting tonight where the TAs will do their final schedules, and I will post all the links in Moodle to the drop-in help. So the typical times are 3 p.m. to 9 p.m. Most days except for Friday and Saturday. So you'll be able to drop in whenever you have a question. And those are in addition to my office hours, which I will schedule once I have theirs. So those will all get posted either later tonight or tomorrow morning. But the drop-in help does start tomorrow. So if you have any questions, you can certainly pop into drop-in help. A couple ways that students use the drop-in help is that sometimes they try the homework and then they sort of flag the questions that they're not sure about, and then they go to drop-in help and they ask about those questions. And lots of students are asking about homework questions. So if you have a question, someone else probably has the same question. And other students will use drop-in help. They'll go to the drop-in help session and they'll mute themselves and they'll work through the homework. And when they get stuck, then they unmute and they ask the question. So if you want to use it as sort of an accountability piece, you can certainly log in and do it that way as well. So you will see on Moodle all the links that, again, that will start tomorrow. And our general rule is that you do not need to have your video on to join the Zoom. So if for some reason you don't want to have it on, that's totally fine. Sometimes it's helpful for us to see your face because if you look confused, that helps us prompt you. But if you are uncomfortable having your video on, that is totally fine too. So The drop-in help is a really great resource, especially for homework or quick questions you have related to the math. Our TAs are really incredible and helpful, and they really want to support you as we go. So thank you guys for introducing yourselves. I am gonna do a screen share. We're gonna pop onto Moodle because that's where most of the files and things that we're gonna be talking about, this is where you're gonna access it. So I just sort of wanna show you where everything is. So, okay. When you log into Moodle, what you'll see at the very top is a picture of me, but also my email address. So if you need to send me an email, just use the email address that's posted here in Moodle, and just make sure that you put something in the subject line related to math. If you leave the subject line blank, it might get kicked to a spam folder. So you can put Math 127 or, homework question, something like that, but don't leave the subject line blank. So underneath that, this is where the times and links for all the drop-in help is going to be posted. And again, those will be posted either tonight or tomorrow morning. And so then you can go to whatever day it is and then see what's available that day and click on the link. So in addition to the drop-in help and my office hours, we are also going to have weekly reviews of different topics related to the course. And we have a grad student named William who is incredible, who will be supporting that. And I'll talk about that in a minute once we sort of get to some of the files. So if you want to know more about me, you can click on this Meet Adina. There's some more information just about like my hobbies, what I like to do, those sorts of things. Now, as I mentioned in my first email, there's going to be 3 ways to access this course depending on your needs, your risk tolerance, your health, all those sorts of things. So I will be beaming in remotely, just like this, every class period. So if you want to come to class, if you like the accountability of being on campus, if you want to meet other people, you can come to Marcus and I will be beaming in. If you are at home, if you're sick, but you want to keep the same time structure, I will be live streaming this same time period. And so the link for that is here. So when you click on that, you'll see this video that you're seeing up on the screen, but from wherever you are. So you can live stream it from your dorm room or the library or something like that if you are traveling. So that's another way you can access the course. And then there are also asynchronous videos that match the same things that we're doing in class. So the asynchronous videos, we'll start with that first, are in each week's heading. So this is this week, January 25th to January 31st. So I do guided notes for all the sections. So the guided notes are here. And if you want to watch the asynchronous videos, the link is right underneath it. So when you click on it, it's going to bring you to a lecture page, which also has guided notes. If you click this little bar, the guided notes are here. But then there's videos that are broken down and it sort of describes where it is in the guided notes. And they're broken down to smaller videos so that if you can't watch them all at once, that's fine. And so these are the videos for the class. So if you want to watch them that way because you have a really complicated schedule, or if you miss a class for some reason, you can watch the videos on the lecture page that we're doing that particular week. Okay, so those are the ways you can access the lectures to the course material. And again, it's flexible. You don't have to commit to one. Obviously, if you're like traveling one week because you're on a sports team or something, you can watch the asynchronous videos and then, come back to attending in class, or if you're sick, but like you have a sore throat and you're just being cautious, you can just hop on the live stream one day. It's a totally flexible and up to you. So that's the sort of lecture part of it. Now we'll talk about the quizzes in a second, but under getting started, you're going to find a copy of the full syllabus. I recommend that you click on that and you download it to your computer so you have a copy. Sometimes if you're going to think about transferring colleges or certain summer programs you apply to want syllabuses of syllabi classes you take. So it's good to have a copy. The homework system that we use is called Wiley Plus. So you'll be doing all of your homework on Wiley Plus. It's all up there for you to see and all the due dates are there. So this right here is the instructions on how to register for Wiley Plus. I highly recommend that you use the instructions. There's big pictures just because there's sort of a lot of weird options you have to go through. And then this is the link directly to Wiley Plus underneath it. There is a discount code, a promo code that you will use so that the Wiley Plus product will only cost $50. So if it looks like it's more than that before the code, just keep going until you can put in the code, okay? You will also see under getting started what's called the algebra assessment. This is a PDF that just has some algebra problems on it. This is just for you. So these are some of the types of things that we do in calculus that we don't explicitly teach because they're from algebra. And so what I would like you to do at some point in the next couple days is just click on it, try some of the problems to sort of gauge where your algebra skills are at, and then the answers are directly underneath it, right? So after you try out some of them, the answers are going to be underneath it. If you are not getting sort of the majority of these problems right, we're going to have a couple workshops in the next week and a half where we're going to go through these. And so I would just recommend that you attend those, or well, one of them, they're all going to be the same, so that you can just brush up on those quick skills so that it doesn't become a problem later. So I'll send an email with all the workshop dates and times on tomorrow. So if for some reason there's some that you don't remember, because it probably has been quite a few years since you took algebra, I would say it's worth it to try to attend one of those workshops just to get caught up, okay? There's also some Khan Academy videos here if you don't want to go to a live workshop, if you'd prefer that. So that's what's under this getting started. As I mentioned, we're going to have weekly sort of review workshops. So this one will be on the algebra assessment, and then there'll be one on graphing, and then there'll be one on like sine and cosine if you haven't done that in a while. And so our TA will record those as well when he does them, and I will post them under this getting started after they've happened. So if you can't attend one of the workshops, but you'd like to see the recording, this is where you'll find them. So that's getting started. And then each week looks pretty the same. So each week we're going to have sort of a lecture that we do on Tuesday, a mini quiz on Wednesday, a lecture we do on Thursday, and a mini quiz and homework due on Sunday. So I want to talk for a minute about the mini quizzes. So the mini quizzes and the homework, okay, these two things are going to pair together to help you prepare for the larger assessment, which is the chapter quiz. So the homework sort of drills down on the formulas and the skills you need to do the computational work, as well as some of the graphical work. The mini quizzes do some of that, but they also are going to ask you some conceptual questions. So there's a lot of mini quizzes over the semester. So if you don't do well on one or two of them, it's not going to be a huge impact. But overall, you want to be getting, the majority of the questions right. So for the mini quizzes, there are 3 questions, and you're going to have 15 minutes to complete it. So the point of the mini quiz is that you attend the lecture or you watch the lecture, you try a couple homework problems just to make sure you got a good sense of it, and then you want to try the mini quiz to make sure that it makes sense. The mini quizzes are open notes, and you can use your calculator, so it's really helpful to have good organized notes. And so the mini quizzes are just to help you figure out what you don't know before the chapter quiz. So the first mini quiz that's due on this Wednesday is a practice quiz, which means the 1.1 mini quiz, which is from the review section, is not going to count towards your grade. It's just to help you understand what the mini quizzes look like. But then Sunday's mini quiz does count towards your grade. So you want to make sure you click on this and take it just to get a sense of what it looks like. But again, this first one is not going to count towards your overall grade. So you have the guided notes, you have the mini quizzes, and then on Sunday, you also have the homework that will be due. That is through Wiley Plus. It is due Sunday at 11:59 p.m. And I highly recommend working on the homework prior to Sunday. I actually recommend working on it prior to the mini quiz and doing a couple problems here and there throughout the week so that you can just sort of finish up things on Sunday. Okay, so that's what a typical week looks like for us in this class. There's some check your understanding problems. These are just extra problems that you can try if you'd like. And every week, like I said, looks pretty similar. So this is this week that we'll do. Next week is going to look the same. These are our lectures, right? These are our guided notes. Then you have your mini quiz, guided notes, mini quiz. Homework is due on Sunday. So that's sort of the bigger overall structure of the course. and how it's run. If you are interested in sort of the grade weighting and things like that, that can all be found on the syllabus. And so, you can sort of see how everything counts and see how you're doing along the way. So the other thing I want to point out is that when these are all collapsed, you can see the due dates for the chapter quizzes. So the chapter 1 quiz will be on February 11th. The chapter 2 quiz will be on March 4th. The chapter 3 quiz will be on March 28th, right? And so if you're someone who keeps a calendar of due dates, those are going to be sort of the major due dates you really want to pay attention to. Otherwise, everything is always due on Wednesday and Sunday for this class. Okay. So those are sort of the broad stroke, big pictures of Moodle, which is where a lot of our work is. Trying to think of what other major things I should mention. So a couple things that are really important. So I want to be really clear about some terminology that I will use today and in the future and what it means by my definition, because I don't want you to interpret some things the wrong way. So the first is that you will hear me use the word review a lot in chapter 1. And so when I talk about review, what that means to me is that at some point, you probably have seen something related to the thing we are talking about. That does not mean that I think you remember it, right? Because it may be something you saw in 8th grade. I don't know, right? And so if I'm talking about being review and you're like, oh man, I don't remember how to do this, that's okay, right? Saying it's a review doesn't mean that you necessarily have to remember it. What it means is that it's a skill that we will use in this class that is not as explicitly taught because it's not a calculus topic. It's sort of a prerequisite topic. And so those are the types of things that we will support. So if we're going over something that's a review and we don't really go in depth, but it's something you feel like you need more work on, you can get help from me at Drop-In Help. You can request a seminar workshop on it. We will support you in that. We just need to know that you need more support in it. So if you don't know how to do something that I'm calling a review, that's totally normal, okay? So the second thing which sort of pairs with that is the word basic. So sometimes when people hear the word basic, they think that it means easy, okay? And I want to be really clear. When I say something is basic in this class, that does not mean easy. It means it's like a foundational building block. So I'll say like, okay, we're going to build the basics of this. That doesn't mean it's easy. It means that's like the first level. So I don't want you to hear me say basic and think, oh, this should be really easy, and then have something be hard and be like, oh, wait, like, I don't get it. So if you hear me say basic, that does not mean easy, okay? Now, in general, we will go through, a lot of steps of problems, things like that. If you feel like you're watching the videos and it's going well and you're doing the homework and you're getting it right and you're doing the mini quizzes and they're going good, then you're probably in great shape. If you're coming to class and it's making sense and then you go to the homework and there's something like, there's problems you're not getting, it's a little bit tricky, definitely reach out and let me know. I'm happy to help you build that bridge because sometimes there's just something small that needs to happen. Sometimes there's just more practice work. But if you are willing to sort of recognize when you need help, I am willing to help you, right? The TAs are willing to help you. We are here to help support you. And the students who reach out for help, are very successful in this class. So definitely don't be afraid to stop by Drop-In Hours and ask questions. I often get students who come in and say like, this may be a really simple question or silly question, but it's a question that lots of people have. So this is calculus, which is like, a really high level of math. So no question you have at this point is silly. And just in terms of like, who's in the room and why you're here, you have proven that you have enough math skills that you should be in this class. So if at some point you're like, oh man, I don't know if I should be in this class, have a conversation with me. But in order to get into UMass, you had to have enough math skills. In order to be placed in this class, you have the math skills. So even if you're not sure about your math, I'm pretty confident that you can succeed in this class, okay? So that's sort of the overview of Moodle. This, like I said, is where most of the resources are that you will need to access. So what I'll do now is I'm gonna ask if you guys have any questions. I may need Rich to translate them to me if I can't hear them. And then if there are no questions or when questions are done, then we're going to move over and start talking about 1.1, which is the first section we cover. So if you have a question, you can raise your hand. And Rich, if you could help me on this part. You see anybody?
See anyone? Stand up if you have any questions. If not.
Okay. Well, if you have questions that either you don't want to ask right now or come up later, definitely feel free to shoot me an email. I'm happy to troubleshoot as we go. So as I mentioned, and I pointed out on Moodle, I like to use guided notes. So those are files, they're all PDFs and linked. So some people like to print those out and fill them out as we go. So if you'd like to do that, they are all posted on Moodle. You can do that as we go. The section we're going to talk about today is 1.1 called What is a Function? So this is like the sort of review part of the class. And so like I said, some of the stuff you may have seen and remember well, some of the stuff you may have seen and don't remember well. Review just means that it's stuff that, you know, we're going to build upon as we go. And so if there's something in particular you don't really remember and it's confusing as we go today, make sure that you go back and either rewatch videos or ask questions as we go. So we may or may not get through all of the review today. If we don't, then, you know, the lecture videos are posted and then the homework is sort of meant to serve as the, you know, what do you remember from before? What do you not remember? So you can always use the homework as a guide. Things you know how to do, great. Things you're not sure how to do, go back and you can rewatch the video or go to Drop and Help or something like that. So I'm going to switch over to my doc cam so we're all looking at the same document. Give me 1 minute. Okay. So today we're talking about what is a function. And this is just sort of the building block of where we're going to be doing a lot of our calculus work. So all a function is a mathematical rule that's going to talk about the relationship between sets of actions and things of that sort. So when we talk about something like f of x equals 3x, you might see something like that. You might see something like y equals, you know, x squared. These are functions, and what's happening is that these operators that hopefully you recognize, like multiplication 3 times x, and we have a variable, they're telling us what operations to perform. So it's exactly what you think it is. It's not anything more complicated than that. But there's sort of 4 ways that we are going to look at functions in this class. And so I'm going to review the 4 ways we're going to look at functions, and then we're going to try some different things on these 4 types of functions as we learn different definitions. I will say in general, I'm not going to ask you for definitions on a mini quiz. I'm not going to say define function, right? This is so that we have a shared common language when we talk about different types of things. So the 4 types, the first type is a formula. So this is like an algebraic formula. We're usually doing some sort of process to this formula. We might be plugging things in. We might be, you know, trying to alter it in some way. But this is sort of your typical formula that you'll see. You'll either have y equals, you'll have f of x equals, you might have y equals f of x equals, or some other dependent variable equals, and then the rules on the right. The second type is a graph. We can get lots of information from a graph. We can get values. We can talk about where graphs are positive or negative, increasing, decreasing. So that's another type of work we do, is we look at pictures of functions and see what kind of information we can get. The third type is a table. So if you are somebody in the life sciences, You probably know that when you collect data, it's not in this nice function form. You end up with tables, right? And so looking at functions in terms of tables, we can sort of figure out some things that are sort of related to what we're interested in, right? So we'll look at how we can use data from tables to talk about different things. And then the last type is going to be our descriptions or our word problems. So we'll also look at problems where we have things written out sort of in words. This is just an example. The cost of ice cream C in dollars at the local shop in Mathtown, Ohio is a function of the number of toppings T ordered to be put on the ice cream. So the cost is a function of the number of toppings. So when we have to read the words and come up with sort of a mathematical idea, that's the fourth type. So those are the 4 ways that we are going to be looking at functions in this class. And there's sort of a lot of things we'll do with them, but those are the types, okay? So now we need to make sure we understand a little bit about variables, right? So this goes back to algebra. So what do variables mean? Again, I'm not going to ask you for a definition. So if you remember this and this all makes sense to you, you don't need to write it all down. But again, this is so we're talking about the same thing. So the input, right, when we talk about variables, is the number that we pick to plug into a function, right? And we might be evaluating that on a graph, on a table. It may come from a word problem, but the input is the number that we pick. The independent variable acts as a placeholder for all possible inputs. So we often use the letter X or T for time as that placeholder, and that's called the independent variable, but any letter can be used as long as we describe it somehow in our setup, right? So you'll see X, you're probably comfortable with X, that's sort of the most common one, but the independent variable is the one we pick. Later on in the course, it's going to be really important that we can discern what is an independent variable and what is a dependent variable. So this is why we want to sort of think about this now. So the output of a function is going to be the number that is determined from that input number. So when we plug a number in, we want to know what number comes out, right? That's the output. And again, we can do that on all 4 types of functions. And the dependent variable is the placeholder for all possible outputs. So this is most commonly used as y. You may see it sometimes as f of x, but it's typically on the left-hand side of the equation. It doesn't have to be, but that's the common convention. So the dependent variable, again, is just that placeholder for possible outputs. So what we're going to do is we're just going to look at one of each type. So a formula, a table, and then a graph and a word problem. And for each one, what we're going to do is we're going to determine the value of f of 2 and discuss the independent and dependent values. Okay, so what does that mean? That means for number 1, we want to find f of 2 in this formula, right? So how would we do that? Well, we're going to plug a 2 into our function. F of 2 means we're going to plug in a 2 wherever we see the variable x. So we have 2 squared minus 2 times 2 minus 3, right? So this is 4 minus 4, which is 0, right? Minus 3 is going to give us -3, right? So you're probably comfortable plugging things in like this, but the way that we really want to sort of tie in what we just talked about, our input here was the 2. Our output was the -3, right? So those are some of the words we used. And then if we look at the original, our independent variable.
Hey, Dina,
Yes.
I can't hear you anymore.
Oh, okay. Let me know when I come back.
No,
Can you hear me now? Can you hear what I'm saying now? I can still hear you. Hopefully eventually you can hear me too.
Can you talk now?
Yeah, can you hear what I'm saying at all?
Are you on mute maybe?
I don't think so. No, I'm not on mute.
Any better?
Can you hear me now? Can you hear me now?
Can you try now?
Yeah, can you hear what I'm saying?
Log out and back into Zoom. I'll try that.
Okay.
Try now?
Can you hear what I'm saying?
Yeah, let me connect this.
Perfect.
Try now?
All right, can you hear what I'm saying?
Yeah.
Perfect. All right, let me go back to the screen share, everybody. All right. So what I was saying is when we tie this particular problem to our terminology, our input was 2 and our output was -3. So 2 is what we plugged in, -3 is what we got out. Our independent variable here is X because that's what's used in the setup, and our dependent variable here is Y. So if we were to do something similar on our table, right? Remember, our sort of overarching problem is that we want to find f of 2. So on our table, the way that we do that is we look for the x value of 2 from the top row, and we want to find the corresponding y value. So here, the y value that's associated, right, is going to be 7. So here again, our input is going to be 2. That's the one that we're putting in, that we're interested in. And our output was 7 from our table. And then when we think about our dependent and our independent variables, this is dictated by where we are on the table. The top row of the table is going to represent your independent variable, which is x. I'm just going to use IV for independent variable because I don't have a lot of space. And then here, f of x is what's representing our dependent variable. And those values and outputs are going to be in the bottom row. So now let's take a look at a graph. Okay. So I'm not sure how well you can see the values, so I'll try to make sure I highlight them a little bit. But if we're looking for f of 2, we're going to look for the 2 along this axis right here, because this axis is going to represent our independent variable, which means that's where our inputs come from. So to find f of 2, we're going to count over to 2, 1, 2. So this is a teeny tiny 2. I can't tell if you can see it. Then we go up until we hit the function, and then we come over to find the corresponding dependent value. Okay, so f of 2 here equals 1. Again, our input was 2, our output is 1, our independent variable is x, and our dependent variable here is f of x. Okay, so same problem, 4 different ways to look at it, right? So graphs and things. So the last sort of one that we're going to look at here is a word problem. And so for the word problem, we have to change it a little bit to sort of adapt for what we're looking for. But we're going to determine what the statement f of 2 equals 525 means. So we want to interpret what the statement means, because we're not finding a value in a word problem. We're interpreting what the problem is telling us. So here, again, the cost of ice cream C in dollars at the local shop in Mathtown, Ohio, is a function of the number of toppings T ordered to be put on the ice cream. So C equals f of T. So this part right here is really important. So the relationship between the variables. It gives us some information about how they're related and what's going to be our input and what's going to be our output. So we are comparing this statement up here to this setup of our problem. So here, C is going to be the cost. So if we look at f of 2 equals 525, if we're going to line these up, the 525 is the cost, and the number of toppings is 2. So if we were going to interpret this statement, we would say something like, if we ordered ice cream with 2 toppings, it would cost $5.25, right? So what's important here is that the number lines up with the right variable so that we get the units right, okay? So our independent variable here is T, and our dependent variable here is C, or cost, okay? So again, these particular definitions are helping us have a shared and common language, and we're just practicing applying it to different types so we see how it comes up. So let's look at our sort of next definition, and then we'll see how we can use it. So the next set of language that we'll use in this class is we will talk about discrete and continuous functions. And before we go through it, I will sort of give you the disclaimer that the majority of the time that we will be working together, we are going to be looking at continuous functions. So what is the difference? So a discrete function is defined only for a set of input numbers that can be listed and nothing in between. Okay, so if you think about the problem we just looked at with the number of toppings, right, you can't have 1.5 toppings, right? Because if you have M&Ms and you have gummy bears, you have 2 toppings. There's no sort of in between, right? A continuous function allows the inputs to be any value in a finite or infinite interval, including fractions, decimals, and irrational values. So the most common sort of matchup for this, although it's not always this way, is that when we look at formulas and graphs, they are going to be continuous most of the time. And we'll talk about, later on when it comes up if they're not. Then when we have tables, that one's a little bit tricky. So we'll talk about that when we look at the table. And then word problems can really go either way. So when we think about this sort of as a concept and an idea, when we have a formula, we need to really think about what that formula represents. So x squared minus 2x minus 3, this is a formula that we can plug in any value, right? So we could plug in 1, we could plug in 1.5, we'll get something as an output. We could plug in -5, we could plug in -45, right? We could plug in pi. all of those things exist and will give us an output. So if we were to draw this, it would be a parabola and it would just be continuous. So most of the formulas we look at, actually all the formulas we will look at are going to be continuous because they have this input value that could be anything, whether it's rational, irrational, things like that. Similarly, this graph is definitely going to be continuous where we see it, right? So here, this is roughly negative 6.5 to positive 6.5. We can see that every single independent value is represented here. So if I were to pick something, here, which may be a decimal, there is an output value here. So this is continuous. One of the ways you may have heard of this is if you can draw it without lifting your pencil off the paper, it's continuous, right? So that's sort of what we see here. The thing we have to be mindful about with graphs is whether or not they go on forever or if they're only defined where we see them. And so sometimes that's given in the problem and sometimes we need to sort of figure it out on the context. But in general, the graphs that we look at will be continuous. And if there's a case where they're not continuous, I will point that out for you. Okay, so then now we'll look at tables. Right? So tables get a little tricky. So if you have a table without any context, this table is discrete because we have no idea what's happening between 0 and 2, right? So there could be holes, there could be jumps, there could be things going off to infinity. We don't know, right? So tables, data tables, without any sort of other information are going to be discrete. However, most of the time, what was going to happen in this class is we're going to say something like, assume we have the data in this table from a continuous function, okay? If in the setup, we find out that this is sort of generated from a continuous function, what that tells me is that there are no crazy things happening between 0 and 2. So we don't have holes, we don't have jumps. There is some way that it's continuous for us to get from 0 to 2. That doesn't mean we know what's going to happen between 0 and 2. We just know that it's continuous in between. So a lot of the times we will give that qualification in a problem and say, this is generated from a continuous function. But if you don't, then tables are inherently discrete because we just have a list of numbers and without any qualification, we don't know if there's any other values that exist in between. Okay. And then again, word problems, right? They could really go either way. It depends on the problem. Going back to our ice cream problem, as we mentioned, here we're talking about plugging in T, which is the number of toppings. So the question is, can we plug in any value of T and have it make sense, right? Because that's the sort of key part of a word problem is, does that make sense? So we can certainly plug in things like 1, 2, 3. You can have 1 topping, 2 toppings, 3 toppings, but you can't have 1.5 toppings, right? So this is an example of a word problem that's going to be discrete because the values in between our list of numbers don't make sense, okay? So again, continuous and discrete is a way that we describe functions that you will see within this class. So the next piece that comes up, I'm guessing you've heard these words before, are domain and range, okay? So the domain of a function is the set of all possible inputs as defined by the function. The creator of the function may also restrict the domain. So what does that mean? That means when you have a function that you are working with, what are you allowed to plug into that function? And when I say, what are you allowed to plug in? This is based on rules that you would have learned previously. For example, if you have the function 1 over x, and I asked you, what are you allowed to plug into 1 over x, right? You could test some values like 2, 5, half. Those are fine, but you would probably notice that we don't want to plug in 0 because we all have been taught the mathematical rule that we should not divide by 0, right? So that's a rule that we'll sort of pull back from our memory and we'll say, okay, the domain of this function will be anything but 0, right? So the domain is what you can plug into a function. The things we sort of typically look out for when we're thinking about domain are things like denominators, right? So is there something that would make that 0? And also square roots, right? We don't want to take the square root of a negative number. The range of a function is the set of outputs for the function while considering the domain, right? So sort of a common example that you see when you talk about range is y equals x squared. So the range here is going to be all the possible y values. We know that x squared only gives us outputs that are either 0 or positive. So the range here would be positive numbers. So we would get values, right, that are greater than 0. So we consider what the function looks like and think about what the outputs could be. Okay, so I want you to try a problem here. And so typically during class, we'll try a couple problems as we go. I'm sort of talking more than usual today because it's the first day. But I want you to think about how we might find the domain and range for the function x squared minus 2x minus 3. Okay, so there's just sort of a graph here if you think that would be helpful. If you have a calculator, you can pull it out, plug in, try some numbers, see what you can come up with, see what you think the domain and range might be. I'm going to give you 2 minutes and then we'll go through it together and talk about how we might figure that out. And also feel free to talk to someone next to you if you're so inclined. You can make a new friend in the math class. See if they're getting the same answer as you. Okay, take about 30 more seconds. All right, so let's talk about what we might do to try to figure this out. So first we look at what type of function it is. So you may recognize this to be a polynomial. You may not remember that, but when you have things like x squared, x cubed, those behave pretty nicely, as in we can plug in lots of things and it doesn't create any problems. I notice that I don't have any denominators here and I don't have any square roots. So what I usually do is I usually try to plug in a positive number, a negative number, and 0 just to make sure that those are all okay, just to give me sort of a very basic, check on that. So if I were to plug in 0. I would take that input of 0. I would get 0 minus 0 minus 3. Okay, that's fine. I got an output. Nothing weird happened. I would plug in something positive. Again, I usually pick numbers that are really easy to work with because I don't want to make anything complicated if I don't have to. So if I plug in a 1, I get 1 minus 2, which is -1, minus 3 gives me -4. Great, no problems there. And I plug in a negative number, see what happens there, right? You could plug in -1, -2, something like that. So -2 is going to give me 4. And then +4 is 8, minus 3 is going to give me 5. So I'm doing this very quickly in my head. You could certainly plug this into your calculator just to double check, but I always do a quick positive -0. So I get the sense, and it will be true, that the domain will be all real numbers, that I can plug in whatever I want and no problems will arise, right? So there's a couple ways to write this. You can literally write all real numbers, okay? So this little symbol here, it looks like a funny E, means X is an element, right? And then you might see this, real numbers. We don't use this one as much, but you may have seen this before. Or we can use what's called interval notation. And so we'll talk about that. That's sort of the next thing we're going to talk about. So we'll come back to the interval notation in a minute, but let's talk about the range. So the domain is all real numbers. I find ranges a little more finicky to figure out. Like, is it going to be all real numbers? Is it going to be some subset of numbers, like in the x squared situation? And so for me, I like to graph things to see if it's shooting off to positive and negative infinity, if there is some sort of minimum that happens. And so that's why I provided the graph here, because that's what helps me. If you have another way of thinking about it, that's fine too. So I'll just plot these 3 points real quick. So f of 0 is -3, f of 1 is -4, and f of -2 is +5, which is way, way up here, sort of above what we can actually see, like right at the top here. But if you were to graph it on a calculator, you would find that this is going to be a parabola, and you might have guessed that because we're talking in a quadratic, and it actually turns around right here at x equals 1. And so what that tells me is that it's going to go up to infinity. So for the range, it'll go off to infinity, but the y values, the minimum y value, happens right here at -4, right? So for the range, my y, and again, I'm going to use this little element symbol, right, is going to have to be between -4 and positive infinity. So I'm going to write the interval notation, and then we're going to talk about how interval notation works. Okay, so the range is all the possible outputs. So there are no outputs smaller than -4. Okay, so let's talk about interval notation, which is part of what this is right here, how that works, what those symbols mean. Okay. So there's 2 types. There's closed interval notation for continuous functions, and there's open interval notation for continuous functions. And we'll talk about what those mean and what the difference is. So closed interval notation means we are including endpoints. Okay. And there's 2 ways that we can do closed interval notation. And so the first way might be something like this. Okay, so x is greater than or equal to some number, but less than or equal to some other number. So for example, you know, if we had 3 less than or equal to x less than or equal to 10, that would mean that our x values could take on any value between 3 and 10 including 3 and 10. And we know it's including because of the equal part of the inequality. Another way that we can write that interval notation is what I was using before. We would say X is an element of A, comma, B. Okay. And so what that means is that X can take on any value between A and B, including A and B. So from this example, right, this would be 3, comma 10. Okay, so these mean the same thing, right? There's 2 different ways to write this notation, but these are closed because we are including the endpoints. Okay, now with open interval notation, we do not include endpoints. So there might be a reason why we're not including the endpoints. When that happens, okay, we're going to have something like this. X is greater than A, but less than B. In an example, let's say 2 is less than X is less than 8, right? That means we can plug in any number we want between 2 and 8, but not 2 and 8. So we could do like 2.5, but not 2. We're not including the endpoints. And so the notation that translates with this type of notation, we're going to use open parentheses, A, comma, B. And for our example, we have 2, comma 8. Okay. So what this means, again, is that we can plug in any number we want between 2 and 8, but not including 2 and 8. One thing we have to be really careful about here is that this looks like a point on a graph, right? That's how we write points, is with open parentheses. And so we have to look at the context of this. So since it's X is an element of, it's actually an interval, okay? I will make a note that infinities are open, okay? So you'll notice that in the problem with the range, when I wrote my interval, I'm going to go back to this for a second, my range, we can include -4. We included that point because we got that value, but the infinity has the open symbol, right? We can't plug in infinity to a number, right? Because infinity is a concept and it's really, really cool, right? There's like countable infinities and infinite infinities, but we use the open notation, whether we have positive or negative infinity, okay? So that's some notation that you'll see in this class. Let's do another quick example here. So assume that the entire function is pictured below in this graph. So this is the value of 1, 1.5, 2, -2, -1, just so you can see where those are. And then we're counting by 2's on this axis. So 2, 4, 6, -2, -4, -6. So if the entire graph is in this picture, then what is the domain and range for this function? And then here, assuming that the entire function is represented in this table, right? What is the domain and range for this function? So notice that we didn't say that this was continuous. So I want you to think about if you might have a suspicion about how we might write domain and range for a discrete function. It's okay if you don't know, you can take a guess. So I'm going to give you 2 minutes to try to think about the domain and range for each of these two, and then we'll go through it together. Okay, so take about 30 more seconds. All right, so let's talk about the domain. So the entire function is pictured, which means that it doesn't go on past what we see. So that means the domain is going to be dictated by where we see this in the picture. So here we can see that it goes from -2 to 2, and we see that if we were to plug in -2, that there is a corresponding y value. And if we were to plug in 2, there's also a corresponding y value. So my domain here is going to be -2 to 2, or we could write that as -2 less than or equal to x less than or equal to 2. Okay, so that's going to be our domain because those are the values that we can plug in, anything between -2 and 2. Now, for the range, what we see is that the outputs, the y values, go as low as -4 and as high as +4. And they don't live outside of those bounds, but we see they take on every value in between. So similarly, here my range is going to be -4 to 4, or we can write this as -4 to 4 with this notation. Okay. So again, a lot of this has to do with the fact that later on, we're going to talk about the domain and range of things we're working on, and we want to be able to quickly look at a function and figure out what that might be. Okay, now let's talk about the table. So here, our table is discrete. Okay, so it says that the entire function is represented below, so we don't have anything outside of the values in this table, and we want to find the domain and range. So this is a little tricky because when we had this interval notation, it assumed we could take on all of the values in between. So how do we write this in such a way that lets the reader know, or the person you're communicating to, that this is discrete? So the way that we're going to do this in this class, and it's sort of the common convention, the notation is going to look like this. So first I want to point out that our independent variable here is t. So I notice that here it's t. So far we've been looking at x, but this one happens to be t. So I'm going to say t is an element of, and now I'm going to use curly brackets, right? So those curly brackets, and I'm going to list the possible t values. So 0, 1, 2, and 3. And I'm going to close the curly brackets. So that gives me a list of the values. And now as the reader, I know that I'm not able to pick values in between, that I have to choose from this list. Now for the output or the range, I'm going to use the dependent variable, which is f of t. I'm going to do the same thing, right? I'm going to list the possible outputs. So -1, 1, 7, 17. Okay. So when you see these curly brackets with these lists, that's telling you what values you can plug in and which ones you can't. Okay. So hopefully this is all making sense so far. Like I said, as we go, if you have questions that come up about the things we're talking about, feel free to stop by Drop In Help, rewatch the videos, read the textbook, all that sort of stuff. Oh, I've just put a light bulb in. The textbook comes with the Wiley homework. So when you purchase Wiley Plus, for the homework, it comes with the e-text. So there's not a physical textbook that you need to buy. I don't know if I said that earlier. I don't think I did. Okay. So let's go back to our word problem. So example 3 here, the cost of ice cream C in dollars at the local shop in Mathtown, Ohio is a function of the number of toppings T ordered to be put on the ice cream. So C equals f of t. If the shop offers 10 different toppings and the cost of an ice cream is given by c equals 5 plus 0.25t, what is the domain and range of this function? Okay, so I want you to take, I guess we'll do 2 minutes. See if you can think about the notation we just learned for discrete functions. This is a discrete function. And think about how we might write out the domain and range for this situation with our new brackets, our new curly brackets. Okay, again, feel free to chat with someone next to you, see if they're getting the same thing, and then we will look at it together. Okay, take about 30 more seconds. All right, so using the same type of notation before, the number of toppings that we could have varies from 0 to 10, right? Because you could definitely pick 0 toppings if you didn't want any, or you could have all 10 toppings, right? So we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And so then the corresponding cost, if you had 0 toppings, would be $5. If you had 1 topping, $5.25. $5.50, $5.75, and you keep going. And then if we had all 10 toppings, right, that would be $2.50 on the variable plus the 5. So the most expensive it would be here is $7.50. I do want to talk about a way that we can write this a little more efficiently, because let's say, for example, you go into the shop next door to this one and they have 100 toppings. We do not want to write out all of the numbers. And because these numbers behave in a pattern, we can use ellipses to sort of shorten what we're writing. So as long as the numbers happen in a recognizable pattern, we could do something like 0, 1, 2, ... 10, right? So the 3 ellipses says continue this pattern until you get to 10, right? So 0, 1, 2, the patterns I'm counting by ones, and I would keep going until I reach 10. The corresponding pattern here On the cost, right, it would be 5, 525, 550, dot, 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 and I keep going until I reach 750, right? So that allows us to shorthand notate a longer list of numbers that follow a pattern, right? So you have to have at least 3 numbers in the beginning to show the pattern, and then you have to tell it where to stop. But that helps us so that we don't have to write out huge long lists if they start to get longer and longer. Okay, so hopefully that makes sense in terms of that. So I think we'll stop here. There are 3 more sort of review topics that I'd like you to watch the videos on. The videos I think are about 5 minutes each. So I'm gonna put this little list right here. Math models, that would be the next one. There's just a couple practice problems. Vertical and horizontal intercepts. How do you know where a graph crosses through? And then how do we know if a function's increasing or decreasing? So those are all linked under the asynchronous videos. And then we will pick up with 1.3 on Thursday.